this video, let's discuss Lomuto partitioning. Let's look at the algorithm, let's break it down, and let's figure out how we can do this. All right, first thing we need to do, let's write out an algorithm. Let's see here, we have Lomuto partition. Okay, so this is gonna be the algorithm. All right, so what are we gonna take in? What are our parameters? We're gonna take in an array that goes from a low value to a high value, and we're gonna call those left and right. All right, for the purposes of this, okay? First thing we need to establish is a pivot. What can we use for our pivot? All right, I'm gonna say that my pivot is equal to the lowest value, so that'd be the L, whatever that is. Actually, no, it was equal to the array at index of L. There we go. Now I'm gonna say that my current, I'm just gonna call it current, and I'll be equal to whatever that number is at L, okay? So now let's make a for loop. I'm gonna say for what? For I is equal to L plus 1. So this is whatever's directly to the right of that element all the way to the right side, okay? If, so let's go ahead and, that's gonna be our curly braces. So if the index of the array at I, okay, is less than our pivot, what do we need to do? What do we need to do? Is less than our pivot. We need to take our current and we need to increment it. All right, let's increment our current, and then we also need to swap. We need to swap A at I, all right, and A at our current. All right, and this may not make a lot of sense just off the bat, but once we actually work through the process one time, it should make a little bit more sense. All right, so we're going to do that for all the elements in the array. And then what are we going to do? We are going to take them, we're going to do one final swap. We're going to swap whatever is the index of the array in the L position and whatever's in the index of the array at the current position. All right, and this will be our final swap that'll swap the pivot to where it needs to be. And you'll see that in a minute, okay? And then of course we will, if we were actually doing this, we would return S at this time, all right? So this is the Lomuto, whatever, potato partitioning for, not S, why am I saying S? Current. Okay, for this thing. So let's actually work this out. Let's see what this looks like. So let's come over here, slide that way, and let's go ahead and let's make up some numbers, and let's actually start working through this equation. All right, so let's have some numbers, some random numbers here. We'll say 5, 7, 2, 1, 4, 9. Actually, let's make this a 6. Yes, okay, that'll work. That'll be our numbers that we use. Okay, so let's keep them on our index. It will be 0. This index position. So these are index positions. So let's have 5. We'll have 5 indexes, just like that. All right. So let's start working through this thing. How does this work? So first, let's establish what our pivot is. All right. Our pivot. I'm going to put that down here. Our pivot would be A at L. What is L? Well, this is the left, and this is the right. All right. So I would say that our pivot would probably be the L. What is L? L is 0 right now. L is the 0 position. Okay, so that would be here. Can you see that? Yes, awesome. L is equal to 0. Okay. Now, so the index 0 in the array would be what? 5, right? So we're going to say that our pivot is right here. Pivot is equal to 5. All right, and that's usually how it starts off. Is always that leftmost index in the array. Okay, what is current? Current is equal to L. Well, we already established down here that L is equal to 0. So we'll say that our current, let's see if I can fit this in here. Yeah, I can do that. Our current is also equal to 0. Okay, just like that for right now. Okay, so we got this in the frame. And I'm trying to fit it all in, and it should work. Okay, awesome. Now let's see here, what's the next step? So now let's start this loop. We got this for I is equal to L plus 1 all the way to R. We're gonna do all of this stuff, all right? So what's this, A at I? So what is I? Well, I starts off at whatever the L is plus 1, so that'd be 0 plus 1, so that'd be this index. So we're gonna say this is I right here. Okay, we have to check. We have to check this index. We have to say, okay, is this index less than the pivot? All right, so we know our pivot's 5, so is 7 less than 5? Duh, no. All right, so since we've already passed that, we realize that, okay, we don't need to do anything in these curly brackets here pertaining to this if statement. Therefore, we can move on to the next one. So 2 is our new I. All right, so is the index I in the array less than the pivot? All right, is 2 less than the pivot? Is 2 less than 5? Yes, it is. So if 2 is less than 5, we need to go ahead and do some stuff. All right, what are we going to do? First thing we're going to do is we're going to take current, and we're going to increment it. All right, so we see down here our current is equal to 0. Let's make that 1. All right, so our current would now be equal to 1. Now what's next? We're going to swap whatever's in the index of I in the array A, all right, with whatever's in the current index in the array A. So we've established our current is 1. We know that I right now is at index 2. All right, I is at index 2. So let's swap that. What would that be? Current would be 1, so let's swap 7 and 2. All right, so because the current is there, so 7 and 2, this would become 2 and 7, like that. All right, awesome. What's next? So we've swapped them, we've finished out the loop. Let's go back up, move over to the next variable. So we're going to go to I is now this one. Okay. All right. So what are we going to do here? So is this index less than the pivot? Is 6 less than 5? Nope, it's not. So we don't even have to worry about it. Let's move to the next element. Okay. So let's make this our I. Now, is index I in the array A less than the pivot? Well, this is index I, which is equal to 4. Is that less than the pivot, which is 5? Yes, it is. All right, so what do we need to do? Let's increment current again. Current is now 2 from 1. We're going to make current 2. Yes, you can see that as being a 2. Awesome. Sorry, my whiteboard's messing up on me a little bit. So now let's swap our A and our I value, or no, our index I in the array and our index current in the array. So what would that be? Current is equal to 2, so that's whatever this is. And we're going to swap that with whatever's in the I position. So we need to swap 4 and 7. Swap 4 and 7. So let's do that right now. So this would be 4, all right, and 7, like that. So we've just swapped those two indexes, and now we finished up another iteration. So let's move I over again. All right, so now I is going to be at 9. All right, what do we need to do here? So is this 9 less than the pivot, which is 5? No, it's not less than the pivot. So we look like we're done with the for loop. All right, so the for loop has been completed. All right, so what's left to do? We need to swap A at the L index, the array in the L index, and the array in the current index. All right, so we know that our current is still equal to 2. We haven't incremented it since then. We know that L is still equal to 0. All right, so it says that we need to swap A at the 0 index and A at the 2 index. All right, so what would that look like? So that would swap this one and this one. So we end up with 4, 2, 5, 6, 7, and 9, like that. All right, and then what do? We return the current. What is current? Current is an index of 2, so that would be 0, 1, 2, this element right here. All right, so what does this tell us? Now that we've sorted, because the array obviously isn't sorted, but what can we notice about this? All right, we notice that everything to the right of 5 is greater than 5, and everything to the left of 5 is less than 5. All right, so we know that regardless of whatever else is in this array, that this element right here is sorted. All right, that is the position it would be in, even if it was fully sorted like so. We know that 5 is still in the same array. So this tells us that this has automatically been sorted. It has been partitioned to where it needs to be in order to be in the correct position as it would be if it was sorted. All right, and this is the whole point of Lomuto partitioning. Now we can combine this with other elements. Other algorithms do really cool things like selecting the kth element and so on and so forth, but this is just the basic gist of it, which is to sort one element out of an array. So I hope that helped you out. Hope you can use that. Once it finally clicked with me, it was kind of neat understanding it. I mean, there's a lot of application here. So if you have any questions, as always, put them in the comments and we'll see what we can do about it. But thanks for watching the video, and I will catch you on the flip.